Good morning everyone. Today I am going to create the video, that is the second video or lecture 2 related with your acceleration diagram. Now in lecture 1 I am going to be here explained what are the rules for drawing the acceleration diagram and what is the exact procedure for drawing the acceleration diagram. Now in this lecture I am going to be explain this acceleration diagram by using this one example. What is the example? From the given diagram, this is given a slider crank mechanism. From this diagram, determine or find out the acceleration of this AB on acceleration of the slider. Now the given, along with this diagram, the length OA 40 mm, length of AB is 110 mm. This crank OA is rotated at anti-clockwise at a speed of constant speed of 300 rpm. This is the angle made by this crank with inner dead center 45 degree. In some numericals, instead of this figure, the statement is given. So from that statement we first draw this diagram and start to solve the numericals. Now I am going to be explain what is the exact procedure from starting, means how to draw the velocity diagram also here included. So this video is very important because in this numerical, in this lecture, whatever may be the procedure of velocity diagram is also covered. So all the students, you must be carefully listen this lecture, how to draw the acceleration diagram and determine the acceleration of this link AB. Now first step number 1, whatever may be the procedure to solve this numerical, I am going to be explained in step wise. In step number 1, we draw the space diagram. We draw the space diagram. This is your step first. Means whatever may be the given data in statement of the question paper or direct figure is given in the statement. So first we draw the space diagram. This is your step number first. Now how to draw this space diagram? Starting from fixed point O, this is the fixed point O. Now O to A, this link makes an angle of 45 degree. So 45 degree makes an angle. Here naming A, this distance O to A is equal to 40 mm. Now this is your one horizontal line. Now A to B, this connecting rod having the length is equal to 110. Take the distance of 110 and mark the cut on this. Join this link. This is A to B. This angle is 45 degree. This O to A is 40 mm. A to B is equal to 110. This is your step number 1, how to draw the space diagram. Now step 2. In step 2, we determine mathematically the velocity of which link having the speed is given. Now in this numerical, for the link O to A, the speed is given 300 rpm. It is rotates at anti-clockwise 300 rpm. Therefore we determine in step 2 mathematically velocity of which link having the speed is given. Therefore the speed of OA link is given. Therefore we determine the velocity of OA in step number 2 mathematically, and the formula is length into omega. Length is nothing but OA distance into omega is 2 pi n by 60. This is your step number 2. Replacing the value of OA, replacing value of the speed and determine its value. The OA is equal to given 40 mm. So converted into meter, 40 into 10 raised to minus 3 into 2 into pi into n is 300 divided by 60. Whatever may be the answer in meter per second. Are you understand? This is your step number 2. Mathematically determine velocity of link. Now next, step number 3. In step number 3, we consider the scale from the step number 2. In step number 2, suppose the answer is equal to 62 millimeter or 62 meter per second. 62.5. Suppose we are going to be consider this answer is equal to 62.5 meter per second. Then we consider the scale here. In step number 3, we consider the scale to convert meter per second into millimeter. Now, in this step, we consider suppose 1 meter per second is equal to 1 mm. Then, the velocity of this link is 62.5 millimeter. Are you understand? In some cases, instead of this 62.5, the answer is, for example, 6.25. Suppose the answer is 6.25. At that time, what is the scale? 1 meter per second is equal to 10 mm. 1 meter per second is equal to 10 mm. Why? Because 6.25 by using the scale 10 mm, 62.5, and this 62 millimeter you can easily draw in your answer sheet. Therefore, we consider the scale according to the answer from step number 2. Are you understand? Suppose the answer vary, then according to this answer we consider the scale in step number 2. Now for this 6.25, 1 meter per second is equal to 25. For 62.5, 1 meter per second is equal to 1 mm. Okay. Now step number 3. Step number 4. In step number 4, we draw the velocity diagram. How to draw the velocity diagram? For that, I am already created that video. So again, I am how to draw the velocity diagram. So for drawing the velocity diagram, starting from fixed point is O to A. For this link, the velocity is perpendicular to this link, and the velocity of OA is equal to 6.25 by using scale 62 mm, and this velocity is drawn perpendicular to OA. How to draw the perpendicular line? By using the drafter. By using drafter or set square, we draw perpendicular to this OA, and this distance is equal to 62 mm. 62 mm. I am going to be consider two lines, 62 mm above, 62 mm below. Why? Because you don't know the velocity of this OA is in this direction or in this direction. For that, we remember this O to A, in which O is fixed and OA is rotated anti-clockwise. Here given, the O is fixed. The first moment of A is upward or downward? Upward. Therefore, we consider that velocity is how much? That velocity is in upward direction. So we remove this velocity. So this is your velocity 62.5 in upward direction. Therefore, here naming is A. Are you understand? Next, A to B. The velocity of A to B is perpendicular to A to B. Now perpendicular to A to B, out of this A to B, A is present. Then from that point A, draw a line perpendicular to AB by using drafter or set square. This is the perpendicular line. So on this line, the point B is present, but there is no exact location. Then how to draw? B is the slider. Again your rule, the velocity of slider is parallel to their direction of motion, and this slider moment is horizontal. Then from fixed point we draw a line parallel to that slider. The moment of the slider is parallel. Then from fixed point draw a line parallel. Then this point is your B point. then remove this, this is your velocity diagram. Are you understand? Now what are the direction? This is the velocity of A, this is the velocity of B, and if the direction is toward this, then its name is velocity AB. If the direction is toward this is known as velocity of BA. Are you understand? And this, all these letters are capital, and here these letters are small. So this is your step number 4, that is the velocity diagram. Now step number 5th. Step number 5th or the step number 1st of acceleration diagram, both are same. So step number 5th is nothing but step number 1st of the acceleration diagram. What is that? Determine the velocity of every link from the velocity diagram. This is your step number 5th. Determine or find out velocity of every link. Now how to determine the velocity of every link? O2 is already known, 6.25. Then measure this distance. Suppose this distance is equal to 42 mm. Then by using the scale divided by 10, the velocity of AB is equal to dash dash meter per second. Next, velocity of B, that is the slider. Measure this distance. Suppose this distance is equal to 55 mm. Then divided by 10, then 5.5 is the answer, meter per second. Are you understand? So this is the velocity diagram. From the velocity diagram, you determine the velocity of every link. In that, OA is already known velocity, A to B is here, and velocity of B is the like this. Are you understand? Next step, step number 6th. Now in step number 6th or step number 2 of acceleration diagram, we consider the scale from this answer. Now here scale. In this step we determine the acceleration of every link. So these are the velocity of every link. The acceleration, which component? The radial component of acceleration of every link is to be determined mathematically in step number 6. That is the acceleration A radial of the first link OA. How to determine? For that your formula is velocity of OA square divided by OA distance. Next, A radial of AB is to be determined. Its formula is velocity of AB divided by AB square divided by AB distance. So these are the only two links, OA and AB. So OA for this radial component mathematically determined. For AB we determine mathematically, and its formula is velocity squared by that distance, and unit is in meter per second square. After that, step number 7th. So in that 7th step, we consider the scale. What is the scale? To convert meter per second into the millimeter or centimeter. Here meter per second square convert into dash dash millimeter or centimeter according to the answer of step number 6th. In this step number 6th, for example, the radial component of OA, for example, radial component of OA is equal to 60 meter per second square. Then we consider the scale 1 meter per second is equal to 1 mm. Same procedure of here scale we are using in velocity diagram. Suppose the answer is 6.25 meter per second square. Then we consider the 1 meter per second is equal to 10 mm. So here the scale to convert meter per second into the millimeter. This is your step number 7th. Now step number 8. In this step we draw the acceleration diagram. Acceleration diagram. How to draw the acceleration diagram? So this is your step acceleration diagram. I am going to be explained in this bracket like this. How to draw the acceleration diagram? We are starting from fixed point. Here, how many fixed point? Only one fixed point. We consider here O. Now, from O to A, it has how many component of acceleration? Only one. Why? For the link OA, it has a constant speed of 300 rpm. For any link, your rule is there are two components. But for some link having the speed constant is given, for that only one component of acceleration, that is the radial. Therefore, for the link OA, only one component of acceleration, that is the radial component. And this radial component you are already determined in step number 7. By using the scale, you draw acceleration for link OA. The radial component of acceleration is drawn parallel to the link. So parallel to the link, by using a drafter or set square, draw a line parallel to the link OA. Now here I am going to be drawn upward direction and in downward direction. Why? Because I don't know the acceleration of this OA is in upward direction or downward direction. So we are going to be here use one of the technique. For that, the radial component is parallel to this OA. Now in this space diagram, OA is in downward and A is in upward. Just opposite of that you are going to be considered in radial component. Therefore, in acceleration diagram, O in upward and A is in downward. Then we consider the following. This line is your radial component of acceleration and here name is A. This is your acceleration of OA. Next, A to B. For this component, there are two acceleration. That is the radial component and tangential component. Now, how to draw the radial component? Again, the radial component is parallel to the A to B. A is in upward direction, B is in downward direction. Then we draw parallel to this. Here O, here A. Parallel to the A to B, draw a line. Here draw a line. And A to B, A is in upward, B is in downward. Just opposite of that, I am going to be consider here in upward direction radial component of acceleration AB, and this is drawn by a faint line or dotted line. What is this? This is the radial component of AB. Okay. Now tangential component is perpendicular to this. How to draw the perpendicular line? Again, this is the perpendicular line. This is the tangential component. So on this tangential component, your B point is present. Now here for B is the slider. Your rule for slider, the acceleration is parallel to their direction of motion. The moment of the slider is horizontal. Then we draw a line parallel to this motion, parallel to this slider from fixed point. Where is fixed point? Fixed point is O. Then from point O, we draw a line parallel, horizontal. Here these two lines are cut here. Therefore, we remove all remaining lines. This line, small line, is A tangential of AB, and this is A to B. Here point B, this is your acceleration of AB. Are you understand? Though this is your acceleration diagram. Just I have revised again, once again. For acceleration diagram, your rules for acceleration of fixed point origin, acceleration of slider is parallel, and for any link there are two components of acceleration. One is radial, another is the tangential. Radial component is drawn parallel to the link. Now how to draw the acceleration diagram? You are going to be start from fixed point O. Here O. First, the acceleration of OA. Here OA, mathematically acceleration of OA, velocity square by distance. By using the scale here, convert meter per second into millimeter. Then whatever may be the here answer, we consider that line OA parallel to the OA. Again, we remember the technique I am given. Parallel to this OA, the acceleration is opposite. O is in downward, A is in upward. So in acceleration, O is in upward, A is in downward. Are you understand? O upward, A. Next, for A to B, it has two components. It has no only one component. Why? There is no any constant speed is given. For AB, one radial component. This radial component is like this, A to B. A is in downward, B is in upward. A is in upward, B is in downward, opposite of that. This is your radial component, and this is mathematically velocity square by this distance. By using the scale, we draw this line. Tangential component is drawn perpendicular to this. Now, after that slider B, so parallel to the slider from fixed point, these 2 points intersect with each other. So this is your point B. So this is your acceleration of AB. This is radial component, this is the tangential component, and this is your vector diagram of the acceleration of AB. So in this way, you are going to be draw the acceleration diagram for any mechanism. You must be remember, by using all the given steps, you solve the numericals. That is very helpful to solve the numericals on acceleration diagram. So I think you must clear every steps of how to draw the acceleration diagram. In this way, you are here stuff. So you watch all these two video. In first video, I am going to be explain here or lecture number 1 of acceleration diagram. In that, only the procedure and steps and what are the rules. And in the second video of this acceleration diagram, I am going to here explain by using these numericals. So step number 1, 2, 3, 4, 5, 6, 7, 8, and in last step, whatever may be the answer, you must be determine acceleration of AB. We measure this distance divided by the scale. The acceleration of slider, measure this distance and divided by the scale. That is our last answer, I think. Okay, stop. Thank you.